All right, so we had 5. Now, two things that I noticed from watching people. When you go in here, you got to put a multiplication sign in there too. Okay, that's one place that people are screwing up. And the second thing is if you are just typing it in, if you just type in cosine, right, like that, you also have to open up a set of parentheses when you put in your variable. Okay? Otherwise, it just recognizes the word cost. Okay? It doesn't recognize that we're trying to take the cosine of t. Okay? All right? So there's that. And then the second thing is, on this one, or the third thing I should say, on this one, it was in theta, but if I'm going to my calculator is a function of t, so I have to change it to t. Okay? And then this next one here would be 5, well, come on now, there it goes. 5 times the sine of t. Okay? And then that was good, that was good, that was good. Enter, there it is. Looks so pretty. Looks so pretty and nice. Capture that page. Let's go over here. Okay, so what figure is that? Circle. What else can you tell me about said circle? What's the main component of a circle? The radius. Yes, the radius. I was just about to say radius. Okay, what's the radius of the circle? 5? Well, when you traced it, you should have found it, right? Because if you would have traced it at t equals 0, my x value here is 5, and my y value is 0. Right? Because it goes through the point 5, 0. And then if you would have went up to pi over 2, you would have gotten 0, 5. Then if you would have went over to pi, you would have gotten -5 and 0. And then if you would have went down to 3 pi over 2, you would have gotten 0 and -5. Now, had you stopped at pi over 4, which is approximately what? Pi over 2 is like 1.65, no, not even, 1.57-ish. So pi over 4 would be somewhere in that, like, 0.76 range, let's say. You should have gotten a value of 3.54 and 3.54. Okay, had you actually traced it around there. Okay. All right. Now, what I would like you to do with that circle is I would like us to now eliminate the parameter. Okay? So, thinking back to last week, how did we go about eliminating the parameter? X equals 5 cosine of t. I'm going to switch the theta to t, and y equals 5 sine of t. Switching them both into t form. How did we eliminate the parameter last week? What do you mean we use substitution? So we solved one equation for t. We solved one equation for t and then put that into the other one, right? Okay, so which equation do you want to solve for t? X or y? X or y? X. Good, thanks. Thanks for picking X. Thanks for playing along. Glad you guys are awake. Okay? X over 5 equals cosine of t. Do I have it solved for t yet? No, how am I going to solve it for t? Inverse cosine, right? So that's going to be the inverse cosine of x over 5 equals t. Right? So now I got to put that in for t in my y equation. Okay? So y here is going to equal 5 times the sine of the inverse cosine of x over 5. Yeah. Yes. Yeah. Anybody want to try and tackle that? Anybody want to try that? That looks kind of ugly, right? Okay? That looks like ouch town, population us, right? So we've hit a wall. We can't go any further, right? So we got to go about this stuff a different way. Okay? And so we're going to actually revert back to our, because I'm using trig, I'm using sines and cosines here. Anytime that I'm using trig, or trig shows up in my parametric equation, I have to revert back to my trigonometric roots. Okay? And your trigonometric roots are forged in the hammer. You started the unit circle with the hammer. Cosine squared plus sine squared equals 1. It's the fundamental law of trig. Okay? It's what everything is based off of. And now I didn't have you remember it because it was all the way back in October when we did it. Okay? But that's where we go. Okay? So instead of solving for t in these equations, in either one of those equations, what I'm actually going to do here is I am going to say x equals 5 cosine of t. Instead of solving for t, I'm going to solve for cosine of t. And instead of solving for t in the y equation, I'm going to solve for sine of t. Because now, when I go to the hammer, I'm going to replace cosine squared with, or I'm going to replace cosine with x over 5. And I'm going to replace sine with y over 5. And I can square those. So this becomes x squared over 25 plus y squared over 25 equals 1. Which, when I solve that, or when I make that look algebraic, becomes x squared plus y squared equals 25. Which fits my algebraic x minus h quantity squared plus y minus k quantity squared equals r squared. That's the algebraic form of a circle centered at the point h comma k. If you go back and look at your graph, it's a circle centered at the origin with radius of 5. So down here in the algebraic form, this is a circle centered at the origin because there's no h and there's no k. Those are 0 with a radius of 5. 25 is 5 squared. Okay? What I would like you to do now is I would like you to graph this function and then eliminate the parameter. Spot check, what kind of a shape what kind of a conic section is what they're called? What kind is that? Does anybody know? What? It's not an oval. There is an actual word for it. It is an ellipse. Good job. Okay? It's an ellipse. Okay? Where's it centered? Where's the center of that ellipse? Centered at the origin. Yep. Okay? Now, an ellipse is a circle that is stretched out either horizontally or stretched out vertically. In this particular case, what is it? Is it stretched horizontally or is it stretched vertically? It's stretched out horizontally. Okay? Now, is there any way we could have seen that this one was going to be stretched out horizontally? So this number right here on the x is bigger than the corresponding coefficient on the y, right? Okay, that's how we see. If they're the same, like in that last one, then it's a circle. If they're different, it's an ellipse. Okay, all right? So when I go to eliminate the parameter, because I'm dealing with trig, right? I've got a sine and I've got a cosine. What do I automatically go to? I go right to the hammer. Yep. So here I'm going to start with the hammer. The cosine squared of t plus sine squared of t is equal to 1. Going right to the hammer. Okay? So if I take this one, that would be x over 3 equals cosine of, we'll call it t for now. So that's going to be x over 3 down there, quantity squared, plus, then this one, I'm going to go and I'm going to say this is going to be y divided by 2 equals the sine of t. So then that's going to be y over 2 quantity squared, and that's going to equal 1. Square those out, x squared over 9 plus, oops, I can actually put this in because it's going to give me the actual one at the end. X squared over 9 plus y squared over 4 is going to equal 1. And that is the equation of an ellipse centered at the origin with a major axis of 6, because it's twice to get all the way across, and a minor axis of 4. The algebraic form of an ellipse is a little more complicated only because A and B are different numbers. If they were the same, then it would be a circle. Okay? What are our guesses here? Well, first off, is this an ellipse? Why? The numbers in front of my trig functions are different. Yep, so it's an ellipse. Stretched out horizontally or stretched out vertically? Stretched out horizontally. Okay, all right. Where do you think the center is going to be? 1 comma negative 2? I don't know. Let's try it. Graph this one and see where the center of that ellipse is. So if we graph this one, what we need to do is we should just be able to go tab and go up and add a +1 there and a -2 there. So now what are we thinking? Our graph is going to shift which ways? Before I hit enter, but my blue graph is going to shift where? To the right 1 and down 2. Okay, let's see. Yep, there it went. It went right 1 and down 2. That's the cool thing about parametric equations, is that everything is as it's written. When it tells you that it's going to, let me shrink this up so we can actually see it here. When it tells you up here that it's going to go, it wants to take your x and it wants to add 1 to it. When it says +1 there, it's literally shifting it to the right 1. It's not like algebra where you got to think oppositely if it's inside of parentheses and normally if it's outside of parentheses and do all that kind of a thing. It tells you +1, that means it's shifting right 1. It tells you -2, that means it's shifting down 2. It tells you that this number is bigger, so that's going to stretch it out along the horizontal axes. Okay? Right? If the y coefficient was bigger, it would stretch it out along the vertical axis. Everything, it's the awesome part about parametrics. Everything is pretty much straight up. Okay? So the center of this ellipse is at 1 comma negative 2. Okay? Now, what I would like to do is now I would like to get into some cool graphs, some cool parametric functions. Okay? So the next part is going to be, I'm going to give you time to type it in your calculator. While you're typing it in there, I'm going to type it in up here, and we'll see what we get. Okay? Here's the first one. Recorder is recording. Good. I'm like, why is my recorder not recording? Okay, fantastic. Where I can't see it. So there it is, my first one. So did you get that one? You got the spiral? Okay, yeah. So when we're dealing with variables, we got to for sure put the multiplication sign in there. Okay, that was one issue. Parentheses might still be another issue. Yeah, that was pretty cool. Okay? All right? What I would like you to do now, don't worry, we're not going to eliminate the parameter on that one. Okay? Now, let's see this cool one. What do you want to call it? Basketball? Kind of looks like a basketball a little bit. Okay? All right? It'd be cool if we could go 3D and spin it, like rotate it around its central axis. Be like a bingo? Oh, a bingo thing, yeah. You only got one though? Because you didn't go your T-step out far enough. Your T-step when we went T all the way up to 20.5. If you go tab. Yeah, you're only going out to 6.2. You're only going out to 2 pi. Yeah. Okay? Alright? Pretty cool. Cool in the game. Okay? That's all I got for you today. Tomorrow we're going to start motion problems. Okay? And we'll deal with throwing stuff and hopefully get to the launcher lab. So we're going to get to the launcher lab here pretty quick, which is going to be awesome. We're going to transform the room into like a human cannonball type of situation. Yeah, buddy.